Hello students, in this video we are going to see exercise 3.12 fifth question. It is very interesting question. In this type of question, it is based on application of quadratic equation. So in exercise 3.12 and its example questions, all those questions are word problems. So they will give a word problem. First we have to convert the word problem into a quadratic equation. Then using any one of the methods from the three methods, we know what are the three methods to solve a quadratic equation. Factorization method, completing square method and formula method. So in these three methods we have to use any one of the method. It is our choice, we can use any one of the method. Using the any one of the method, we have to solve that quadratic equation to find the answer. So the major thing is how are we going to convert the word problem into a quadratic equation. So here in this question, a pole has to be erected at a point on the boundary of a circular ground of diameter 20 meter. So there is a circular ground. There is a ground is in the shape of circle. Okay, so we know the circle, this is the center, and in the question itself it is given the diameter of a circle is 20 meter. So diameter is a chord which is passing through the center, that is the diameter. Okay, then another thing in this question, it is given in such a way that the difference of its distance from two diametrically opposite fixed gate P and Q and the boundary is 4 meter. Okay, first in the first line, a pole has to be erected at a point on the boundary of the circular ground. So in this circular ground, a pole means it is a kambam. So a pole has to be erected any point on the circle, on the boundary of the circle. So here there is one pole on the boundary and two gates, this is gate 1 and this is gate 2. Two gates or two different gates P and Q on the boundary. So these two gates are diametrically opposite. So the distance between the two gates 20 meter, because the diameter is 20 meter. And in this question what we have to find, the question itself, question they have asked, is it possible to do so? If the answer is yes, at what distance from the two gates should the pole be erected? So from this gate, from these two gates, at what distance the poles may be anywhere, here, there, and wherever it may be. So at what distance? So we have to find the distance, two distance. So and you have to you have to note that P and Q as on the boundary, the difference, the diametrically opposite, the difference from the two diametrically opposite fixed gates P and Q and the boundary is 4. So this is P and Q are the two gates, and the difference from the pole is 4. So which means if it is x, it must be x minus 4, because, or we can take x plus 4, because of it is little small, I am taking x minus 4. If you want to write, if you can take this as x and this as x plus 4. anyway the difference must be 4. So x minus 4, it is correct. X plus 4, that is also correct, we can take. So the pole has to be erected is PQ. We can take this one as R. Let R be the point of pole erected. Let R be the point of has to be erected. Okay, now we are going to find those two distances. So we have to find x to find PR. Then if you reduce 4, then we can find QR. So P and Q are two gates. P and Q are two gates, and R be the point of the pole has to be erected. Okay, now we have to find PR. So in the question they have asked, in the pole, the gate lerundu enna distance la irukum, இந்த ரெண்டு கேட்ல இருந்தும் இந்த போல் வந்து எவ்வளோ டிஸ்டன்ஸில் இருக்கும், அதான் கொஸ்டினில் கேட்டிருக்காங்க. போல் வந்து எங்கே வேணாலும் போட்டலாம். ஓகே, தென் you should know this. In a semicircle, a triangle drawn along with its diameter must be a right angle triangle. It must be a right angle triangle. Anywhere we can draw right angle triangle. Definitely any triangle drawn in the semicircle must be a right angled triangle. So here PQR is also right angle triangle. So in a right angle triangle, the square of the hypotenuse is equal to sum of the square of the remaining two sides. So the square of the hypotenuse, so if it is 90, the opposite side, the diameter must be the hypotenuse. So the square of the hypotenuse is equal to sum of the square of the remaining two sides. Then we can expand x square plus, using a minus b whole square, x square 16 minus 4 2 8x is equal to 20 square 400. Then x square plus x square 2x square. We have used here a minus b whole square identity. A minus b whole square, a square b square minus 2ab. So x square plus x square 2x square minus 8x plus 16 minus 400 is equal to 0. 2x square minus 8x minus 384 is equal to 0. We subtract. Symbols are different, so we have to subtract and put the big number symbol. Now we can divide all these terms by 2. We divide by 2, x square minus 4x minus 192 is equal to 0. So now we have to factorize to find the value of x. Their product is minus 192. Their product is minus 192 and their sum is minus 4. What are those two numbers? 12, 16. 12, 16. So 12 and 16 means you give minus to this, 12 minus 16. So now you can see plus into minus minus, 12 16s are 192. Symbols are different, so subtraction 16, 12, 4. 16 minus 12, 4, big number symbol minus. So x minus 16, x plus 12 is equal to 0. So x minus 16 must be 0 or x plus 12 must be 0. X is equal to plus 16, minus 16 becomes plus 16, x is equal to plus 2, 12 becomes minus 12. So what is x? X is the distance between P and R. The distance never be negative. So this is not possible. Negative numbers not possible to be a distance. Therefore, x means PR is equal to 16 centimeter. If PR is equal to 16, what is QR? QR is 16 minus 4. So 16 minus 4 is equal to 12 meter. So these are the two distance. The distance from the pole